Hi guys, this is Janani from second year ECE of Panimalar Engineering College. Today we are going to see about Darlington Transistor, electronic component made by the combination of two BJTs connected in such a way that it allows high amount of current gain. The emitter terminal of first transistor is connected to the base terminal of second transistor. So, the base supply is given to the first transistor and output current is taken from the second transistor. Let us now see a small example of Darlington transistor. As I have said, I have connected the emitter of first transistor to the base of second transistor and included the voltage supplies VCC equal to 5 volt, VEE is equal to minus 5 volt and resistances of 1 kilo ohms and 20 kilo ohms. Let us now run this transistor. We get IC1 is equal to 249 microamps, IC2 is equal to 3.53 milliamps. So what we can infer from this is the current amplified by the first transistor is further amplified by the second transistor. Let us now see the AC analysis of Darlington transistor. I have included the capacitors of 100 microfarad and this AC input. This AC input has an amplitude of 20 millivolt and frequency of 1 kilohertz. Let us now see the input waveform of this transistor. I am enabling show waveform and when I run this transistor, we get a minimum value of minus 22 millivolt to maximum value of 18 millivolt waveform. And now I am disabling the input waveform and enabling the output waveform. And now we get the waveform from the minimum value of minus 19 millivolt to the maximum value of plus 19 millivolt. And now let us see how this transistor works as a switch. Here I have included the voltage supply of 10 volt and this is an LED and this is a normal switch. You can see it. And now when we run this transistor, we see the LED glows. This is because the Darlington transistor allows the current to flow through and thus this Darlington transistor acts as a switch. Now I have shown the small signal equivalent circuit of Darlington transistor. Let us now proceed with the calculations. We all know V is equal to I into R and for V by 1 the current is II into R by 1. And then for V by 2 the current is II plus GM1 into V by 1. So we write V by 2 is equal to II plus GM1 into V by 1 into R by 2. For calculations we need GM1 into V by 1 and GM2 into V by 2. So we multiply GM1 on both sides and here we multiply GM2 on both sides. Let us now find the current gain. AI is equal to I naught by II. I naught is equal to GM1 V by 1 plus GM2 V by 2. And substituting the values we found in the before slide, we get II is equal to beta 1 into beta 2. That is, the overall current gain is the product of individual current gains. And now let us see input resistance. Input resistance Ri is equal to Vi by Ia. Vi is equal to V by 1 plus V by 2. And substituting the values we found in the before slide and approximating it, we get Ri is equal to 2 beta 1 R by 2. That is, the input resistance is large because of beta. Let us now see the advantages of Darlington transistor. A typical Darlington transistor has current gain of 1000 or more. So, only a small base current is needed to make the pair switch on higher switching currents. It offers high input impedance, which translates into an equal decrease in output impedance. It is a single package, so it is easy to configure on a circuit board or PCB compared to connect two different transistors. And the applications of Darlington transistor are power regulators, audio amplifier output stages, controlling of motors, displaying drivers, controlling of solenoid, light and touch sensors. Thank you.